hero got stayed on my desk.
Wherever makes your heart happy. Tell us about your hero, though. Huh?
Stay outside.
Why? No.
You should stand anywhere.
Walter, inside the room so we can learn.
Oh, Walter.
My hero money is Mr. McKinney, because if I didn't know all of this stuff right now, I wouldn't even be in this 11th grade.
Quick question. Mr. McKinney?
Yeah, Mr. McKinney.
Kenny.
Mystic.
I was just curious, because then you started talking about all this stuff, and I'm like, I mean, maybe McKinney's class helps you. Well, I appreciate it, Walter. Let's get it going, though. Learn some more of this stuff, right? All right. So we've got sequences versus continuous functions on the docket today. We need to learn a little bit more about what makes something a sequence or makes it a perfect. Thank you. No, run to the bathroom and grab one. Okay. I think that's all needed. So just don't let me forget to take this back over there at lunch. Okay. I need to buy some, but we still haven't gotten that teacher money yet. You know, that they give to teachers to spend on classrooms. All right. Mr. Anderson, if you could just be prepared to pass this out.
Yeah.
So, as I said, linear and exponential functions, domain and range. I am going to do a quick little recap and reminder, though, of what did we study on Friday?
Work.
No, we didn't study work. We studied
domain and range.
We did not study domain and range. Oh, we studied what a function is. We got to remember that. So remember, Friday was all about what is a function. So, remember, that is, I can determine if a relation is a function. Now, I want to start with this reminder, because, again, we got to know our language, we got to know our vocabulary. What is a relation?
Same? No, not the same.
No? You're trying to get to, let's pause. Hey, right here. What is Finney trying to talk about when he says the same inputs mapping to the same outputs, but what is that? Equivalent. We got to remember, the same inputs mapping to the same outputs, that's an equivalent relation. But what is a relation in general? Just inputs mapping to outputs, right? And we can represent those relations in lots of different ways. Jaden, tell me one way that we can represent a relation. Well, I'm going to come back to you in a second. Someone said it. Oh, a graph is one option, right? Tables. All right, Jaden, give me one more. We got graphs, we got tables. We can use words, right? Verbal representations. Amaya, give me one more. Pictorial, right? We can draw pictures. Abby, give me the final one that we're missing. Algebraic, right? Like we can represent our relations, our mapping of inputs to outputs with those 5 mathematical representations. You got to remember that. We got to be able to justify and think through those things. We're developing our logic and reasoning. Now, we have started talking a decent bit about y-intercepts. I should probably include that more, but we haven't directly addressed it. Later today's lesson, we're going to get heavily into domain and range. So please notice we should have everything here done. I should have highlighted that in green at this point. We should be able to go from tables to graphs, graphs to tables, verbal to tables, etc. We're going to continue practicing it today. Please notice, we're not leaving anything behind. We're going to continue building on all the things we've been working on, and then identifying if two relations or functions are equivalent. Okay? From there, please notice arithmetic and geometric sequences. If you look at that proficiency scale, how much of it should you hopefully have checked off as mastered?
All of it.
All of it, right? We need to make sure we have all of it. Which you have practice questions and answer keys, I believe. Yep, I'm looking at the answer key right there. So you have practice questions and answer keys for that information. And I just realized...
Wait, what did it look like? When did you pass it out?
I passed out the answer keys on last week, some point. And Mr. Anderson, I just realized I've made this got this practice for the students last Friday in 3rd block. Totally forgot to do it for this class. Can you make 21 copies? No, I think it was like Tuesday or Wednesday.
So
Yeah.
copies of this.
Yes, you saw them keys right there. Okay. Sorry, 21 copies, yeah. Okay. Actually, I need some for my fourth log as well, so can you make 30 of those?
Okay.
Thank you.
Yep.
Alright, so, I will look for extra copies of the answer key, but it's just this, it's lesson 2, lesson 3, growing dots, and growing dots, right? So you should still have that practice, but the answer key as well. And so, Mr. Anderson is printing out some practice that goes with what we've been working on as well, and answer key, so you have that. Okay. But we need to be able to find constant differences, constant factors, arithmetic, geometric. You need to be able to write recursive equations and explicit equations. That's the practice I gave you last week. What Mr. Anderson is printing out also has some practice, so that's good news. Alright, so what we did was what in the World Cup? The FIFA World Cup, and we talked about all of these different relations, right? The mapping of the year to the host country, the year to the number of goals scored, mapping the winner to the number of goals scored. Right, so when I look at this, right, when I look right here, what made something a function? Actually, better question is, what made the relation winner to goals scored not a function?
See that question, like I don't know. That's what I'm saying.
I don't know what you're saying. Come on, we gotta know this. Maybe we have some notes on this task that told us a little bit about why a mapping of winners to goals scored is not a function. I know someone's got to remember this. Okay, so one input mapping to multiple outputs. Remember, if we have a function, if I know the input, I should automatically know the output, right? But if I ask you, hey, when Germany won, how many goals were scored?
We don't know.
We don't know. Why don't we know?
Because Germany won 1-4.
Right. Germany maps to 140 goals scored, 97 goals scored, 115, and even 171. So what's the answer? I don't know. Remember, the whole idea of a function is when I substitute an input in, I should automatically know an output, right? But if that one input maps to multiple outputs, it's not a function, it's just a relation. Still useful, but not as useful. But when we looked at the year, if I knew the year, did I automatically know the host country?
Yes.
If I knew the year, did I automatically know the winner?
Yes.
If I knew the year, could I automatically find the number of goals scored?
Yes.
So that input of year always had only one output, no matter what the output was, which variable it was, and so those were all functions. So when we talk about concept of functions, if I ask you about functions, right, can I see this really quickly, Emily? Right, we should have this sheet and be able to refer to the back of it where we have our quick notes. And if I ever ask you about what is a function, you should be able to refer to this. You should be studying this. And then what Mr. Anderson is printing right now is a chance for you to practice these things. I do want to remind you, I talked about it after, was it last week's reflection where I had you answer the question of like what's a suggestion you would make for someone who is struggling? Was that last week? It was something like that. And I think like some of the things, oh that's right, because we also looked at what are some of Mr. Kenny's go-to sayings, right? And so the go-to sayings was take chances, get messy, and make mistakes, right? So that's how learning happens. P.S. Who was I quoting there? Miss Frizzle, we gotta know that. The other quote, what was the other quote that y'all all refer to? Oh, I don't care when you learn, I care that you learn. Right. I was even showing Mr. Anderson, remember, the DYUs to the test, right? On the first DYU, everybody but 5 people showed growth, right? From the DYU to the test. And so your grades corresponded, huh? Your test? Oh, the last DYU? No. I saw that this morning and I was like, but I will, okay? So those are things to keep in mind. But also the suggestions, some people are watching the YouTube videos that I post. Some people, at least a couple people, I don't remember who it was, are actually doing the practice assignments. Guys, math is different. I need y'all to hear me on this because I'm having to teach my stats kids this. They're AP level students, I'm still having to teach them. Math is different than any other subject in the sense that you need to study the concepts, right? Like most of the time in a lot of history classes, in a lot of English classes, you mostly need to focus on just learning the content, just learning the concepts, right? And study over your notes, etc. then you have to apply it into a novel question, but you still mostly need to just study the content. In math, more than anything else, if you don't practice putting those concepts of, if you don't go through putting those concepts into practice, that's what I'm trying to say, with practice questions, with homework, you're really going to be up a creek when it comes to assessments. Some of us can master it right away, right? Like I know Malia because I had her 2 years ago in geometry. She figures things out really, really well from the get-go. Most of us are not like that. Most of us need to study. Take advantage of the opportunities to grow. Mastering is not something that necessarily should happen all the time in the classroom. It also needs to practice outside the classroom. All right, today, what we're focusing on, we are going to understand, which we're going to be continuing with all the stuff we've done in the past, but we are going to expand into what are called linear functions and exponential functions, what do linear and exponential functions really heavily tie into that we've been studying this whole time? Arithmetic and geometric sequences. Remember, when we looked at an arithmetic sequence graph, what did it look like? It looked a whole lot like a line, didn't it?
It's a linear line.
You can just say it was linear or it was a line. You don't have to put both of them, right? Okay. But it was just discrete or not discrete. Thank you, Dean. And then a geometric sequence. We talked about the shape. What was the shape of that geometric sequence? It was an exponential curve, right? So we got to know these things. But this is really where we're going to focus today. What is the difference between can you go ahead and pass one of those out? That's the practice assignment that Mr. Anderson just printed. So a packet, yeah. Yeah. So the packet may look long. It's actually only 2 assignments. But I went ahead and put the answer keys with them so you could check yourself. So I went ahead and gave you the answer keys because remember you need to be able to check yourself to make sure that you're getting it right or wrong. That's why the bell ringer is what's the question you have. Okay. We need to be working now on graphing functions by hand using key features, both of exponential and linear. We're going to be working on that. We need to develop tables of inputs and outputs based on any representation. But what we really have to be focusing on is explicit equations for linear and exponential. Notice that's the focus. There's only one. Well, I'll hold off on saying that. But right now, we are going beyond arithmetic and geometric to linear and exponential. Talking about functions with constant rates of change.
You gotta say
yes, it's somewhere in the back, I believe. I'll have to look for it though. Okay. One thing I actually realized that I skipped, that I want us to look at.
thank you. Homework.
Yeah, some of them are answer keys. Homework.
Oh, he said some more answer keys.
Yeah, ones are bad. I think
First I'm going on.
Dude, this is the answer key.
Oh, no, it's not. Okay, never mind. I was thinking of a different one. Okay, so here's what we're doing. We are looking at 4 different contexts. Either something to do with a piggy bank or something to do with a pool, okay? And so there is something about numbers 3 and 4 that I need to give a little bit of direct instruction when we get there, or structure it slightly differently. Oh yeah, we need to actually pass this out. Can't get half of them, you can take half of them to just be there. Alright. So, yeah, it would help if you actually had this assignment. Okay?
Oh, don't do it like that.
By the way, I will point out at this point, if you have not realized it, I would probably get a 3-ring binder. These are your practice questions. This is the lesson.
Right, don't be getting done, so it's like, I'm just keep moving my
Why,
Man,
Jaden, why do I talk? Hey, we need to do what we can. I know that.
Why is you talking to me like that? I ain't gonna do nothing.
Jaden, I literally just said, hey, this is the practice assignment that Mr. Anderson just passed out, and this is the lesson.
When I said as in another one, I wasn't talking about.
Mr. Kenny, should I leave the rest of them back here?
I'm talking about tables.
Oh.
No.
My bad, Jaden. Okay. So, right here, we are looking at my little sister Savannah. She's 3 years old, she has a piggy bank. So, notice, what mathematical representation are we starting with here? I would say, what is given to us? Verbal, right? Can you, no, word problem, but verbal, right? Can you make a graph first? Yeah, can you make a table first? Can you make an equation first? Yep. So you are going to work with your small group to build a table, a graph, and an equation for numbers 1 and 2. If you finish number 2 early, then go ahead and feel free to start on number 3, but be aware there are things we're going to have to talk about with number 3 before we get too far. Now, you need all of numbers 1, 2, 3, and 4 on your vertical surfaces. So you may need to write a little bit smaller today to make sure that you can put a graph, a table, and an equation for the first 4 problems. There is a reason why I need you to do that. So trust me, on your vertical surface, how many tables, graphs, and equations do you need? 4. Make sure you label them. Maybe you put quadrants up there so that you can put your 4 different pieces. Finney, what you got? So today's the 15th. Okay? All right. So let's get up. Let's get working on these verbal representations, making graphs, tables, equations. Use each other as a resource. Grow and learn together. Nope, we're starting now. All right. Hey, literally, I said the center, and everybody's still on the outside. The center is right where Dean is. I need y'all to move forward. You're also not moving. Guys, I need y'all to move to the center so you can see the different graphs. This is not me asking you. I'm telling you. Okay. Now.
I actually had a camera there. Wait, you made it.
Oh my gosh, you giant baby. Move still to the center. Alright, so, hey guys, first things first. Were we able, hey, I'm speaking, I'm teaching. Okay, Parker, you literally just moved from one corner to the other. That's not the center. Okay. When you look around the room, first off, were we able to find a pattern or a starting point and a pattern to figure out how many pennies and how many gallons we have going on? Yes. Yeah, right? So what was the easiest representation for us to start with? A table, right? Okay. So we have tables all around. That was a great place to start. Was it easy to make a graph with an equivalent set of inputs and outputs? Yeah, right? Tables are great to start with. And a lot of us were able to use that table to make an equation, right? Jason. 1, I'm trying to teach here. 2, I don't need the attitude. Parker, also, just be nicer about the way we open it. Like, y'all trying to be...
Wait, what I do? What is the matter?
Did you see how you responded to Parker coming through the door?
They homeboy, they good.
I understand, but like it's still disrespectful, and yeah. I want us to learn how to actually talk to human beings.
He ain't let me in.
They good, they homeboy.
Did I just address that with Parker and tell him that he should have been nicer as well? Yeah. You're both in the wrong here. Don't act like either of you's in the right. Okay? Talk with each other and be polite to each other inside my classroom. Alright, so here's the discussion point. So I'm going to talk about the equations a little bit, but what I mostly want to look at really quickly is this. Hey guys, some of us with number 1 made our graph how? What's different about the 9s versus the 8s for number 1?
What's the difference?
Oh,
Yeah.
one of them made them. Wait, it's a
They
line.
put a line through their graph. I thought
Okay.
they were supposed to put a line through your graph.
Well, but that's what we need to discuss. That's what I need to hear. So first things first, when you say they put a line through it, that means they made their graph what here?
Linear. No,
Discrete.
constant. Continuous.
Continuous. Okay? Guys, I need you to recognize that this is continuous. Whereas over here, how did they make this graph? Well, which one's right?
8, 9.
I thought
9.
arithmetic couldn't be discrete.
Now, hey, once again, see, this is why I wanted you all in the center of the room instead of on the edges.
Because
It's
they
hard.
not paying attention.
Boy, shut up.
You part of the problem. And also, it's harder to see from back
Oh, I
there.
can see you. I'm 7 foot tall.
It's like, man, Mr. Kinney, you don't know what you're talking about. It's not like you've been teaching for over a decade.
Yes, Mr. Kenny, you know what you're talking about.
So right here, okay, let's think about the context, because here's what I need us to recognize. Right, Finney, was it Finney you were saying that you didn't think it could be continuous with an arithmetic sequence?
Well, he said discrete.
You didn't think
It could be,
it had to be discrete, you didn't think it could be discrete? Okay, now first off, I will point out, with sequences, the graphs or the functions are always discrete. Sequences are always discrete. But did I ever tell you that this was a sequence or whether it was continuous?
No.
No. Okay, let me ask you this. What was the context for number one again? I'm coming home and I'm giving my little sister, what, 3 pennies every day.
Every day you go to school.
Every day, go home, give 3 pennies to my sister. So here's the thing, here's the question. Is there at any point where my sister has 10 pennies?
No.
No. Guys, it goes straight from 8 to 11. Does the sister ever have anything in between?
No.
So can we draw the stuff in between?
No.
So should this have been discrete or continuous here?
Discrete. No.
This should have been discrete.
Yeah, discrete.
Can't get the stuff in between. Stuff is a very imprecise word, which is why I'm putting quotation marks around it. Can't get the stuff in between. So it is discrete. I want to point out, if it's happening every day and at the end of the day, it's happening all at once. And I'm going to add that detail later. But if it's happening all at once and it's not continuing throughout, it's not continuous, it is discrete. Man, that was a terrible way of writing discrete. There we go. All right, now over here at number 2. Okay? Number 2. We started at minute 0, because that's when the person started measuring. But started at minute 0, and there was 5 gallons of water, and every minute that went by, there were 2 more gallons of water, right? Now, at some point, was there a place where this person had 6 gallons?
Yes.
So, we had 6 gallons somewhere in there, right? Does it show in that table?
No.
No, but if we're filling up a pool, is there some point of the pool that has 6 gallons? Right? It doesn't go straight from 5 to 7, it has to get stuff in between, right? Is there a point where it has 6.5 gallons?
Yes.
What about 6.57 gallons?
Yes.
What about 6.57,
Yes,
8, 6, 3?
Yes.
Alright, so I know we're laughing about this, but I need y'all to see this. Does that mean I'm getting everything in between
It's
6 and 7?
Continuous.
It's continuous, right? So this one is continuous. Now, I'm going to pause for a second. I want to point this out. Are we talking about categorical or quantitative variables here?
Quantitative.
They have to be quantitative, right? Like, they're numerical values that we are either counting or measuring. Hold on to that, because that's actually going to be important later when we talk about discrete and continuous. Now, I'm going to have to erase this because I know you all need some more room here. But at this point, right, so we can't get the stuff in between, so it's discrete. Oh, the other thing I wanted to caution and point out to y'all, be careful with your graphs. A common mistake is that we are not correctly applying tools. Remember, when you make a graph, you need the right tools. Talked about this earlier in the year. What do we need if, when I say tools, what do we need? Title, units, labels, and scale. That's the biggest one. So, I mean, first things first, I want us to recognize, I do actually really like this. I didn't notice they did this earlier. But notice, days. 1, 2, 3, 4, 5, right? Okay? Now, 5, 10, 15, 20, 25, what? Pennies. Notice these labels also have my units involved. Okay? Now, again, notice scale. Scale is one of those things, I will point this out, and I might put these white books up later for all the different groups, but it's easier when you have a coordinate plane. You have the grid system like the aces do back there, okay? But be careful. That's one day. Notice it's about the same length, and then they have day 2, day 3, day 4. If you're doing this by hand, you can't do it perfectly. Please understand that. But it is still very useful to make sure you're being attentive and careful. I will point out, this doesn't look perfectly linear. Well, first off, we need to erase that. But 2, part of that's because, you see that how short that distance is? But then the distance from there to 10, you see how that's so much longer? That's throwing the graph off a little bit. So be careful and attentive to those things. Now, I'm going to pause here. And we're going to come back to all these ideas later, but I do want to point out in number 3, so everyone needs to, actually let's just look up here at the board real quick, I'll put number 3 up. So overall, we also need to talk about the equations a little bit, I think, right? Yeah, okay. Overall, we're doing better on the equations, okay, but I do want to point this out. Thank you, Dalton, I was just about to ask about that. Really quickly, I want to remind y'all, okay? What does this, hey right here, hey guys, what does this multiplication by 3 mean? Not just adding.
Division.
I asked, what does this multiplication right here mean? It's something important.
It's the constant,
Constant
difference.
Constant difference, it's constantly and repeatedly. Jaden, do I need to collect your money so that you can focus?
$1.
Yeah, if we can't focus, put it away. You and I both know that's what I'm really saying is, put it away. Okay, so, hey guys, multiplication is constant, repeated, addition. When you look at this table, quite literally, the y-intercept is starting at a what? 5. And what are we doing to that 5? We are constantly adding 3. That's why we multiply by d to show, hey, on day 1, how many 3s have I added?
3, 5.
How many 3s?
1.
On day 2, how many 3s have I added? 2. On day 3, how many 3s have I added? 3. So however many days, that's how many 3s we've added. It is telling a story. We need to learn how to read that story. Over here, because I don't see their table yet, and so I will point out, if you have not done number 2 yet, you're just going to have to use another group's number 2 later. But here on this one, we're adding 2, right? So, F of, what is it, minutes? I'm going to do G of M because the number of gallons based on the number of minutes. How many gallons did we start with? 5, right? What's repeatedly happening to that 5 every minute? We're repeatedly adding. But how am I going to show that I'm repeatedly adding to?
Power. Explanation.
Remember, a power is that repeated multiplication and division. We're repeatedly adding, so we need to multiply. Okay? I will again remind you, hey, if we have constant repeated addition, that's like a linear. What's the slope-intercept form of a line?
Y equals mx plus b.
Y equals mx plus b. Notice that group over there wrote it out in that same exact way. 2 times m plus 5. Is 2 times m plus 5 telling the same story as this?
Yes.
Yeah. Notice it's still 2 times m, indicating we're constantly, repeatedly...
Multiplying.
Nope. Adding. 2 times m, constant repeated addition. What did we start at? How many minutes, or how many gallons? 5. So telling the same story. But you need to recognize it's linear, so we're constantly, repeatedly adding. Now, I will agree, I'm seeing Coriana write this down, it's probably a good idea. I'm going to give you all a couple minutes to write these notes. I'm literally, why are you laughing at her when I'm saying that she's doing the right
I'm not
thing?
laughing at her, I'm laughing with her.
No, because she said,
It's not calling you out, I'm giving you props.
he giving you props.
So, let's take some notes on numbers 1 and 2, then I'll get us started on a couple of details of number 3. If you need help with an equation or a graph, let me or Mr. 1 and 2, sorry. You should not have 3 yet. Okay, so right here, okay, I'm more sophisticated than my little sister, so I save my money in a bank that pays me 3% interest on the money in the account at the end of each month. If I take my money out before the end of the month, I don't earn any interest for the month. I started the account with $50 that I got for my birthday, use a table, a graph, and an equation to create a mathematical model. So, I'm going to just kick this one part off to show this, make sure that this is clear, okay? Hey, right here. So, month 0, we have how much money?
$50.
$50. At the end of month 1, I have a new amount of money. Specifically, how much money did I gain?
3%.
3%
Oh my God.
of what?
$50.
Of $50. Now, I want to make sure that this part is clear. And I'll go ahead and tell you this. I'm going to show you a faster way to get to this later. But how do I find 3% of $50?
Divide.
Say again. Guys, I want to point this out. I need y'all to understand because I know a lot of times, even in my AP Stats class, kids were like, Mr. Kenny, I don't know what to do with the percent. Break the word down. Right here, let's start with cents. How many cents, how many pennies are in a dollar?
100.
Okay, there's 100 cents per dollar. Okay? How many years are in a century?
100.
100 years. Any guesses about how many soldiers were in a Roman centurion?
100.
100. Right? That prefix cent, and also I should have just done centimeters. How many centimeters are in a meter?
100.
100. That prefix cent means?
100.
100, okay? Now, what mathematical operation goes with the word, or the prefix per, or word per? Per.
100.
Division. So, when Malia said 3 divided by 100, that's literally what that word is saying. 3% is 3 divided by 100. Now, whenever you have a fraction of, or a percent of something, what operation do you need to do?
Divide.
No, that was the percent we need division. But when it's a percent of, or a fraction of something, you need to multiply.
Yes, sir. Wait, so anything, so a percent is out of 100?
Yes.
No.
Okay.
Oh my God.
So you always get, percents are out of 100. That's why I broke that word down, to help us understand. Okay, so 3% of 50, how much is that?
1.5.
It's $1.50. Notice how I also include my context in there, I don't just put out a number. Okay, so at the end of month 1, how much money do I have?
1.5. $1.
But I started with $50.
Wait, hold on. 51.
So remember, I started with 50. That's how much I gained. So how much do I now have? $51.50. Okay? Now, what I want you to work on first at this point is I want you to work on making a table up to, let's say, 4 or 5 months. And then I'm going to show you something that might help speed things up if you don't find the pattern later. Okay?
Wait,
So-
we're on vertical?
Yeah, we're working on this on vertical surfaces. Guys, numbers 3 and 4 need to go on the same vertical surface as what you already been working on. So let's get up, let's work on number 3. Make a table first, please.
Can we really write?
Dollars. And so 51, or month 0 was $50, month 1 was $51.50. And so we made month 2 $53, just adding $1.50 every time. However, what does it say? It says 3% of, let's see.
3% of 50. No, 3% each month.
Yeah, 3% per month, right?
Yeah.
But
Interest.
at the end of month 1, how much money do I have?
$51.50.
I have $51.50, so I need 3% of that $51.50. Okay? So, some of us have already started to do this. 3% of $51.50 is how much money?
Wait, what calculator?
Wait. Hey, Brianna, I'm literally talking about why we don't do that.
Oh.
This is why when Mr. Kenny talks, we listen. Oh, Leo killed me. What is 3% of $51.50? How do we have so much food when we went to get water?
Wait, what did you say?
It's
3% of 51.
$1.
I don't know how to go back.
It's $1.
That's
1.545.
Hey, listen, I can hear.
Hey guys, right here, okay?
I can't hear.
But we could also just retype this. 3% is 3 divided by 100 times 51.5. Notice, do we add the same amount this time?
No.
Is it close? Yeah, but is it the same amount? No. So how much do we actually have? Is it 53.045? Notice I had to take that 5150 and add this to it. Now, for month 3, I need 3% of 53.045. How much is that? 3% of 53 cannot be 50 something. I'm just asking what is 3% of 53.045?
Hold on, wait, hold on.
I don't even know what he
Not
asked.
do that to the
What's
ruler.
3%
Break the
of-
ruler.
So 3 times?
What is it?
On my fault.
3
Don't
Say
feel
it
that
again,
way.
William.
It's 1.5.
You did it in the calculator a moment ago.
It's not 1.5,
Yeah, I'll
not
look it up.
1.5.
It's gone.
1.59135.
Thank you. Now I add that, and so I'm up to 54.63. Is it 64? 6364, that makes so much more sense. Okay. So, notice, and this is what I want us to recognize. Hey guys, could that be a pain in the butt to have to do that every time?
Yes.
Now, this is where understanding functions matters. So, is this arithmetic, or do you think this might be geometric? Why is it geometric? Why not arithmetic?
We could just multiply.
Maybe, but you haven't checked to find that out. Why don't you think it's arithmetic?
Because there's not nothing to add by. It is.
But see, that's the thing. Hey guys, I need y'all to recognize, I'm not saying this for kicks and giggles. I'm saying this because we all need to pay attention to this, Coriana. Guys, adding. We have been adding this whole time, right?
It's not constant.
But it's not constant. Like, this is why we got to understand these sequences. Are we adding in here? Yeah, sure. But are we constantly adding by the same amount? No. So we want to recognize that this, I'm going to have to erase part of this. This is not arithmetic. So it might be geometric with a constant, not difference, what's geometric?
Oh, backtrack.
Factor. You good over there, Finney?
Yeah, I'm just having a little, yeah.
Okay. There's 2 things I'm going to point out here. And I need you to hold on to this because it's going to be in the next couple of lessons so that you can speed this process up. First off, if we think it's a constant factor, I'm starting at 50, I'm multiplying by an unknown factor and getting what? 51.5. So let's write an equation. What equation could I write off of this?
That's why we're
We're going to have to divide it, right?
Can you just tell me what equation we could write off of this? No. Just off of this. I got to find my factor.
50 divided by 51.5.
We're not subtracting. And it's not 50. What did you say it was?
Wait, well, number 1, I said 50 divided by 50.
It is not 50 divided by 51.5. Guys, I need y'all to actually pay attention when I teach this because I need you to hold on to this and go back to this. Guys, I'm starting at 50, and what am I doing to the 50?
We're going up.
We're not going up, we're not adding, we are multiplying. So 50 times my factor
We don't know it.
is, hey, you know what I can put in this place of it is? Hey, oh, say it again. Equals, guys, when you say the word is in mathematics, that's equals. Equals what?
We don't know.
Yes, we do. 51.5.
Yes, sir.
Oh, times. Okay, I see it.
Right? 50 times my factor is 51.5. Wait, so that's an equation I
Are we
can
looking
solve.
for the factor?
Yes.
Okay.
Yes. Because we think it might be geometric, which means we need the constant factor. P.S. Could that factor help me write the equation?
Yes.
Yes. Okay. So what do I now need to do?
Don't you divide?
Notice, Finney, how it was the reciprocal of what you said. You said 50 divided by 51.5. Guys, if you just try to do it in your head, it's super easy to make a mistake. If you write that equation out, though,
I got it.
what you got?
And then you add that. 1.03.
What? Alright, hold on to that. I'm going to come back to it. I need to check this. By the way, I have not proven it's a constant factor. I've just looked at 2 numbers. But what should I be multiplying by every time?
1.03.
Alright, hey,
53.045.
why don't you take 51.5 and multiply it by 1.03? Let's check it.
53.045.
Did it actually do that? Did you check it? Okay, 53.05 times 1.03, what do I get? Oh, 54.6364. Hey guys, does that mean I have a constant factor here? Yes. So this is why we need to understand our functions. Hey, could it have taken a while to keep doing 0.03 times the number, then adding, and then 0.03 times the number, and then adding? What's easier, doing that or just multiplying by 1.03?
Multiply by 1.03.
Multiply by 1.03. Hey guys, I want y'all to understand, when it's a percent of, it's geometric in there, okay? Now, here's the last thing I want to point out. Because can you do this? Sure. Would you like an easier way to find that factor though?
We actually go to the vertical, which actually makes it work, which is kind of cool. But, and that'll help you for number 4 too.
Hey guys, right here, increasing. What mathematical operation can you think of?
Increasing, multiplying. Adding.
If something's increasing, isn't it going up or just adding?
It's going up.
It's adding, okay. Adding by 3%. Now, we'll point out, isn't 0.03, that's 3 divided by 100?
Something like that, boss.
300ths right there?
Yes.
Now, it's going up by 3%. What percent did it start at then?
0. 50.
If you got everything, you started at what percent?
100.
100%.
Oh, I forgot, yeah. Good like
So 100% increasing by 3%, what's 100% going to be as a decimal?
100 decimal
0.01.
It's going to be,
1.
isn't 100 divided by 100?
One.
1? Hey, do you know what 1.1 plus 1, or 1 plus 0.03 might be?
0.04. 1.03.
Wait, you mean the same as this factor we just got right here?
That's what I mean. Oh, tripping.
I need y'all to see this, and I need y'all to recognize this. If you had realized, hey, I'm increasing by 3%, you could have written the factor of 1.03 from the beginning. Okay? Now, here's the thing, and I want y'all to hear me clearly on this. I don't expect you to have seen that factor of 1.03 from the beginning, because I've had experience and most students don't see that before they get here. That's perfectly fine. But at this point, I need y'all to start to realize that if we are increasing by 3%, then what percent do we start with? 100%. And I will just point this out. What you could have done is, what's 100 plus 3? 103%, right? 103% of the previous value. 1.03 times the previous. 1.03 times the previous.
So we
Now,
got that?
yes.
100 plus whatever number.
If it's increasing by a percent, then we want to recognize that you are getting to that factor of 1.03. Hold on one second. I will point this out though. I want you to think about it. If it was decreasing by 3%, what might you do?
Divide. Subtract.
I would say increasing was adding, right? Decreasing would probably be subtracting. Okay, I need y'all to continue working on your tables and your graphs for numbers 3 and 4. We have to finish through number 4 so that tomorrow we can pick up with 5, 6, and 7. So, let's get to our vertical surfaces. Let's finish the table, the graph, and the equation for numbers 3 and 4 in the next 14 minutes. Yes, sir.